H goes to 0. All right, I'm going to replace all my what's with a plus h? All my t's with a plus h. So we have 5 minus, I'm careful here, 5 minus a plus a.
5 minus a minus h.
Let's make this a group quiz. Why don't y'all work together to see if y'all can get this? Just work together. Group quiz as in like, you know, participation quiz. Do what you can, but I want you to work, see if you can help each other out, do the algebra. I'll come around and answer questions, all right? Do this on a separate piece of paper. I do want to turn it in. Yeah. Pardon? I passed around the quizzes. Are there any other quizzes passed around? There's a stack here. Yeah, here we go. Here we go. Is that what you're talking about?
Yeah.
Okay. This is a group project. Does that make it feel better to you?
All right, so we got fractions over h. So you think of denominator, or you said it should be?
I want to go no more than like 15 minutes.
Okay. Should be the bottom, right? The denominator?
Yeah. So for like the first little term, I have 5 minus 8.
So it's 8 minus 5 minus 3, 2a plus 2h.
So now when we look at it,
So there's a minus sign, so we got to put it in.
halfway through the first multiplication. All right, 5 times 5, 25. And then 5 times negative a is negative 5a. And then 5 times negative h is negative 5h. All right, I'm going to need a lot more room here. Then I have minus, right? So I'm going to be subtracting from this whatever I get when I multiply out the second one, which is here, 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 and then here, here, here. 6 multiplications. 15a is my first one, plus 15h, plus 25, minus 3a squared, minus 3ah, minus 5a. Yeah, a little bit of room for error here, huh? A little bit of room for error? All right, so I'm going to now distribute a minus sign through all of those, right? Yeah. And that's going to change the sign. So when I do that, let's see. I'm not going to show it, but these would go away, right? Because that's going to become a minus 15a. What about that minus 3a squared? It's going to become a plus. So that's this. Oh, the 25s, right? Positive 25 is going to become negative, and it's going to cancel with that. Anything else cancel? 3ah. That one and that one go away. And the 5a, geez. Right, realize I'm canceling those only after that negative went through. I just didn't want to have to write everything again. So what's still up top? Minus 20h, right? Because you have a minus 5h minus the 15h. So I'm going to write this line. Limit h goes to 0. I have minus 20h over my common denominator, 3a plus 5, 3a plus 3h plus 5, and then all of this is over h. And those h's can now go away. And now I let my h go to 0. Limit h goes to 0. I'm sorry, I'm letting it go to 0 already. I don't know why I wrote that down. So if h goes to 0, I get negative 20 on top. Nothing changes on that, 3a plus 5. And here, that goes away. So I get another 3a plus 5. And so my final answer is negative 20 over 3a plus 5 squared.
Can we leave it like without the square?
Huh?
Can we leave it without the square?
You could leave it like this, but I mean, this will be, you'll do this later because it's just, we're going to need to do something with it. Yes?
How do we go from negative 5h to negative 20h in the numerator?
That's a negative 5h, right?
Yes, sir.
And then that's a 15h, but I'm subtracting. So I was checking the answer here. So I'm telling you, we're going to have a shortcut, right? Later. So this. I want you to see how fast the shortcut is. All right. You won't understand what I'm doing, but I'm just going to do it visually. Okay. It's negative 1 times 3t plus 5 minus 3 times 5 minus t over whatever the bottom is there squared. Okay, so that's it. I'm done. This is the derivative. Now what I would do is distribute this through negative 3t minus 5 and then distribute through. You get negative 15 plus 3t all over the 3t plus 5 squared, and the 3t's cancel. And notice I get negative 20 over 3t plus 5 squared. That's the same answer over here, except I'm using t instead of a. Do you all see that? So that didn't take me very long, did it? No, there's no limit at all here. So we'll learn this. These are the shortcuts. You'll learn this. This is going to be known as the quotient rule. But we're just not there yet, okay? So there's light at the end of the tunnel, kind of, a little bit here. But you're going to have to keep suffering through the limit a little bit. So for homework, I realize your homework, you're going to be studying for a test. We are a little bit behind, okay? We were supposed to start 2.2 today, all right? Right? I think we were. Let me check our schedule. Let me see here. Yeah, today was supposed to be 2.2. So don't do anything for 2.2 homework. I'm going to have to change that, all right? But for 2.1, I asked you to only do what, numbers 3 through 6? Yeah, for 2.1? Oh, I did say 25 through 30? Okay. Okay, very good. Then for those problems, what I would say now is feel free to use either definition. All right? You can go maybe back and try them with the other definition now that you have both definitions. Let me see if there's anything else I want you to look at. Yeah, I think that's okay for now. You have enough to do, right? To get ready for the test. All right, so I've left myself 15 minutes. No, not quite. 12 minutes. Are there anything over the review thing I sent you that you want to talk about? Number 7. What was number 7? I don't have it in front of me, so.
Tangent of 4 theta over tangent theta.
Tangent 4 theta, limit, theta goes 0. Tangent 4 theta over tangent theta. So I'm asking, what's that limit, right? So the first thing you have to know is what happens when you just replace theta with 0. So what's tangent of 0? Right, if you replace theta with 0, this is 0, tangent of 0 over tangent of 0. What's tangent of 0? 0. Pre-cal? Tangent function? Pi over 2, negative pi over 2. Zero, tangent of 0, 0. So this is 0 over 0, right? So this is bad. We've got to do some sort of algebra or some sort of trick, right? So what I told you to do with these is to start ripping everything apart, right? So I'm going to just write it like this. I'm going to write limit theta goes to 0. I'm going to write it this way. Tangent 4 theta over 1 times 1 over tangent of theta. Just going to kind of take my time through this. This is limit theta goes to 0. Tangent of 4 theta is sine of 4 theta over what? Tangent by definition is sine over cosine, right? So I'm going to write it like this. That's same, right? That's tangent of 4 theta. Now, I also need to do 1 over tangent theta. 1 over tangent theta. So isn't 1 over tangent the same as cotangent? Isn't that just the reciprocal of tangent? So instead of sine over cosine, it's actually cosine over sine, right? Let me write it this way. Tangent of theta, I'm going to write it on the side. 1 over tangent theta is cotangent theta. But that's just equal to cosine theta over sine theta. It's the reciprocal of it's the reciprocal of tangent, right? That's what that is, the reciprocal of tangent. So instead of sine over cosine, it's cosine over sine. So I'm going to write it like this. Cosine theta over 1 times 1 over sine theta. Is that fair for me to write it that way? Any questions on that? Tangent of 4 theta. This is 1 over tangent of theta, just rewritten.
So we have to introduce the junk.
Yeah, we have to introduce something, right? Good. So what piece of this is causing the problem?
The last one.
The last one, because the last one gives us division by 0, right here. Otherwise, there's no problems, right? This is, if you replace theta with 0, sine of 0 is 0. 0 over 1 is 0. Cosine of 0 is 1. 1 over 1 is 1. Cosine of 0 is 1. 1 over 1 is 1. Okay? 1 over sine of 0 is 0. Division by 0. There's the problem, right? That's the problem right there. So now I need to see this sine junk over junk thing, which means I would love to have what up here? Theta. I can't just throw a theta in there, right? Just out of the blue. I have to multiply by theta over theta. Then I can slide this here.
But you need a 4.
Yeah, but so now I have an issue, right? I'm putting that in there. I'm going to put it right there like that. Theta, make that a 1. So I've solved this, right? This is no longer a problem. This is the junk over sine junk. The junk matches, and they both go to 0. So I know that now goes to 1, right? But now I have division by 0 here. But I've got this sine 4 theta over there. It's just like over here, just like minding its own business. And I can use this to get rid of that problem here by sliding that theta underneath here. But I also need to put what here? A 4. So I'm just going to introduce a 4 over 4 back here. And then slide the 4 under here. Okay? And now just look at all the pieces and see what happens to them. Right? This is sine of junk over junk. That goes to what? 1. Okay. 1 over cosine of 0. Cosine of 0 is 1. That goes to 1. 1 times 1 times. Cosine of 0 is 1. 1 over 1 is 1. That goes to 1. Times. Junk over sine junk goes to 1. Good. What's still left over here?
4.
Just 4. Right? 1 times 4. These are gone. We slid those over. So our answer is just 4. Look, on the test, if you take this problem and you just say 4, you give me the answer and no work, you're not going to get credit, okay? I mean, I understand it's just 4 from that. I understand that, but can you do this? Yes?
Can you leave it in terms of tangent, though, if you understand that tangent theta over theta is also equal to 1?
Is tangent theta over theta also equal to 1?
Well, no, it is, but I mean, so can I leave it in terms of tangent? Because if you take tangent theta over theta, you've got sine theta over cosine theta times 1 over theta. You flip-flop them, and you get sine theta over theta times 1 over cosine theta, which is 1 over 1.
So I guess what you're asking me is this.
It's tangent of junk over junk equals
Oh, yeah, junk. Let's do junk. Can you say tangent junk over junk? Can you say that that also equals 1?
only if it's going to 0.
Yeah,
Yeah.
you can do that.
So I don't have to break it up into sines and cosines or...
You don't have to.
Okay.
That's all right.
How is the cosine, 1 over cosine 4 theta, how's that one? Is it just, because like wouldn't it be multiplied?
What's cosine of 0?
1.
Sounds like you're guessing.
It's 1.
How do you know?
Because the point, like the...
How do you do it in your mind? How do you do that? Cosine of 0.
To visualize the unit
The,
circle?
the unit circle. Okay, yeah. So when you're on the unit circle, cosine of 0, you're at angle 0, which means you're here, right? And that's the ordered pair 1, 0, and cosine is always the x-coordinate.
But like, because there's a 4 there.
But you're letting theta go to 0, right? So if you do 4, if that's becoming 0 times 4, well, 4 times 0 is still 0, right?
Yeah.
So the 4 really doesn't matter because you're multiplying it times 0. Okay, other questions? We still have just a few minutes. I wanted to look at what I sent you all. What is it? Does it say anything on it? Like spring exam 1 or something like that? What does it say?
It was just an exam, it was like SP something on it.
SB something.
22.
Okay, so this is my spring 22 exam. I just gave that exam. Let's see. Exams, exam 1. Does that look like it? Yeah. So I've sent this out to everybody. I would highly highly advise you to look at this. Make sure you understand how to do it. So the first problem, I give you a graph and I ask you for a bunch of different things. Limits, function values, what's the limit as x goes to infinity. Then I give you the conditions and have you draw me something. We did that in class, right? You remember doing that? And then a major part of this test is limits, right? It's all limits. So remember, the first thing for every limit is always plug in, see what happens, right? So let's see, on that first one, I believe we do get 0 over 0. So on that first, or for number 3, you got to do some factoring, right? Difference of squares on top, it's a quadratic on the bottom, you factor it. On number 4, you probably could just expand 3 plus h cubed, just multiply it out, 3 plus h, 3 plus h, 3 plus h, and then you'll get an h to cancel. How about number 5? You get 0 over 0. Conjugate. Okay, number 6. Common denominator first. And then I think after common denominator, you're there. Number 7 is one we just did. What about number 8? As x goes to 2, where does the top go?
2.001.
So the top goes to a number, doesn't it? Fixed number on top, and the bottom goes to 0. What happens when you have fixed over 0? Infinity, negative infinity, or does not exist. You have to figure out which one it is. Number 9, same scenario. If you let x go to negative 2, your top is fixed, your bottom's headed to 0. You got to figure out what's happening. It's either infinity, negative infinity, or does not exist.
Yeah, number 8.
So 8 and 9 are pretty much the same sort of problems, right? And then number 10, you get infinity over infinity. So that's where you had to come in with the highest power of x in the denominator, try and make it multiply through top and bottom. Remember that? 11 is infinity minus infinity. So you can either factor or you can do a conjugate. I showed you that in class as well. Okay, number 12, don't worry about. And that's all I had on that test. So there's still stuff missing from this test that would be on yours.
Are the tests going to be about like the size, or is this like just an example of part of the test, or is it going to be like it looks like 12 questions?
Yeah. So what I normally do when I make a test is I make the test, and then I take the test, and then you're going to have 100 minutes, right? So I should be able to finish it in like 15 to 20. If I can finish it in 15 to 20, then I think it's a fair test. That's just my standard. So it really doesn't matter how many problems there are. It matters more of can I finish it. But this is an example. I think this test could have been longer, but I guess when I gave this test last spring, we hadn't covered the next bit of material. You can have, in addition to this, me ask you for the stuff like we were doing today, right? Maybe not that complicated, but like the problems that I sent you home with last time, those sorts of things are fair game. It's not on this review, but it's on a homework assignment that I've already given you. So I would definitely know how to use that top definition for sure. If you want, you can use this one, but know how to use that on some pretty basic functions. It won't be like the one I just gave you, and it won't be like the one I gave you before that one with the square root 9 over, 3 over square root of 9 minus x. I won't give you that, but all right, anything else? Yes?
So the only thing due Thursday morning is 2.1, 3 through 6, and 35 through, or 25 through 30?
Yeah, and just however you want to do those. You can do them with the first definition and be fine, or you can do them with both, or yeah, that's it. So what